Did you know that Americans discard 30 to 40% of the food supply every year? This food waste accounts for 8% of human-generated global greenhouse gas emissions each year.
In addition, the less MSW that one household provides, the more carbon emissions are reduced from garbage trucks and landfill processing. By cutting down the amount of organic materials that end up in landfills, toxic leachate can be avoided from leaking into groundwater and thus polluting freshwater sources.
Several states have begun to restrict the amount of food waste going to landfills, ban food waste scrap altogether, fund private sector composting and organic collection programs, and fund food waste task forces to create and fund composting education and infrastructure. Many people, especially in the younger generations, are interested in composting their waste but are limited by the price, ugliness, odor, and lengthy processing time of existing compost bins.
We've heard these consumer concerns, and we believe that our Renewable Rubbish composter successfully tackles all of these issues. As seen here, we use an anaerobic microbial accelerator which kickstarts the composting process in a minimally odorous manner and produces a nutrient-rich leachate tea. Compaction further reduces the compost time by bringing all of these essential elements closer together. To prevent odors from leaving the bin, we've installed an activated charcoal filter that traps both smells and bacteria. We've designed the system to directly use this leachate tea as a nutrient source for an attached hydroponic garden, which helps to hide the indoor composter while generating yummy foods for your family. To top it off, we've made this design affordable and attractive by using the cheap and sleek, high-density polyethylene material. Our product will help you convert your disgusting waste into delicious leafy greens that will save both your family's nutrition and the environment.
By considering all these factors, Renewable Rubbish is proud to contribute to the health and environmental efforts of every user's home.
Our compost system works by having the user place food waste and the microbial accelerator into the blender, which deposits the finely chopped food waste into one of 3 bins. As the microbial accelerator works, water and nutrients will collect at the bottom of the compost bins. After a certain period of time, the nutrient-rich tea will be channeled into the hydroponic system where different types of plants or herbs can be grown. After all the nutrients have been leached from the compost, the remaining solid waste or pre-compost can be taken out of the compost bins and used in a variety of ways. Having 3 bins will allow the user to continuously compost by filling one bin as the composting process takes place in the other bins. The features of the composter were dictated by the results of our experiments.
We broke our experiments down based on different design aspects we were considering for our composter. For each experiment, we used a large bucket with an airtight lid and a spout for leachate extraction. The control bucket only contained food waste and no powdered microbial accelerator, or PMA. The Bokashi bucket contained food waste and PMA. The rough cut and fine cut buckets contained food waste and PMA. However, the fine cut buckets had a larger surface area since the food was blended more finely. The experiments I just explained were a batch process, and we are currently testing a process in which the compost is added continuously and compressed or stirred to see if this should be a design feature as well. As seen in this graph, the fine cut compost started producing leachate the fastest and at the most rapid rate, indicating that a blender would be beneficial in our design. The buckets with and without PMA performed similarly, but further experimentation is needed to determine if there is any nutrients in the leachate from the control bucket. However, the Bokashi powder was still deemed a necessity, as it reduced the odor of composting significantly and halted the growth of mold.